So the experiment is determination of Stefan Boltzmann constant, and the aim, as the name suggests, is to determine the Stefan Boltzmann constant. So this is the connections that we need to make. This is the black body radiator, and the ammeter and voltmeter are already given. So we just need to connect it to the display, the positive to the positive and the negative to the negative for both ammeter and voltmeter. Then this is the black body radiator, which you need to connect across these given points, and this is the digital thermometer, which will measure the temperature. Then we need a stop clock to measure the time. So the formula to find the Stefan Boltzmann constant is sigma is equals to E by 8 t to the power 4, where E is the thermal energy, A is the total surface area, and T is the surface temperature. We need to find the temperature and also the area. To find the area, we need the diameter. To find the radius, it is already given in the black body radiator. So initially we are going to set the voltage to 3 volts and then wait till the temperature reaches 35 degrees Celsius. So this is the start time, that is when you start taking these readings, that the time on the clock you write it here, and then we need to do the experiment really fast because when you are taking the readings you might exceed the time of wait. So only after the temperature reaches 35 degrees Celsius, then we start to vary the voltage, and corresponding to the value of the voltage, the current you get, you note it down, and then you find the power by multiplying voltage and current. So now that we have the values of the power, using this graph we'll find the translation time, that is whatever value of power we get, we see where it coincides with the graph, and then we take the value of the translation time. Although it is given in minutes, so we have to note down in seconds so that it's easier for further calculations. So the time on the clock, you can write it in two ways. The first one is you can just write the values diagonally, and the second one is you have to add whatever minutes or seconds you get here to the start time on the clock. For example, here is 180 seconds, so 3 minutes. You add it to 10:12, so your time on clock for this one becomes 10:50. So after we have gotten the time of wait from the graph, you need to wait exactly 180 seconds from the start time, and then whatever value you get at the end of 180 seconds, that will be your temperature. So after we get the temperature, you need to change the voltage very fast and then note down the current and power, and then find the time of wait again, and then you have to wait exactly 300 seconds from the start time, and then note this value of temperature. So from the previous table we have got the power E, and then we know the area, we have already found the area, so we find the value E by A. Then we know the value of temperature corresponding to each powers. We convert it into kelvins, then we put it to the power 4, and then we put it in the formula E by 80 to the power 4. The value of sigma for each power should be almost similar to each other, and the average of the values that we take will be your Stefan Boltzmann constant, which is 5.64 into 10 to the power minus 8 in this case.